This video demonstrates the operating procedures for the Dynatel2273 Advanced Cable and Fault Locator. Updates to this program have been added, which includes information describing enhanced features that are available on newer model locators only.
This is the Dynatel2273 Advanced Cable and Fault Locator. It's rugged, water resistant, it's lightweight, well balanced, and it's easy to operate. The transmitter is used to apply a signal to the conductor you want to locate. The receiver is used to trace the path of the signal. Now, in addition to detecting the transmitter signals, the receiver can also detect signals from energized power cables. When you're tracing a conductor, this bar graph and numeric indicator shows the signal strength, which is at a maximum when you're over the cable in peak mode. And there's an audio response that gets louder as you get closer to the conductor. In addition, there's a directional or differential mode that points to the cable's location. In this mode, the unit makes a distinctive warbling tone as you move to the left or right of the cable. The receiver lets you get an estimation of the conductor's depth and signal current at any time simply by pressing the depth key, even when you're tracing a power cable. And if you have a Dynatel 2205 or 2206 EMS marker locating accessory attached and set to the alert mode, you can locate a marker at the same time you're tracing the conductor path. Or, if you're using an active duct probe to locate the path of or find an obstruction in a non-metallic conduit, you can use the receiver to locate the probe and to determine its depth. The switches are used to turn the unit off and on and to check the batteries, to select the trace mode, to select the appropriate frequency, to select the fault or tone modes, to adjust the speaker volume, to adjust the gain or record a fault level reference, and to measure the conductor depth or the current through the conductor. On the bottom of the receiver are two jacks. The smaller jack is for headphones. The larger jack is for accessories, such as the earth contact frame for finding sheath faults, the dynacoupler for cable identification, and the tone probe for pair identification. A standard toning coil for aerial fault locating can also be used. The transmitter has storage space for cables, ground rod, and some accessories inside the case and in the external pouch. The switches are used to turn the unit off and to check the batteries, to turn the unit on in the ohms mode to check loop resistance and foreign voltage, and to put it in the fault or tone mode, to turn the unit on in the trace mode, to select one of 4 possible tracing frequencies, or to select all 4 frequencies simultaneously, and to select normal or high power level. There's also a display and an output jack. When you're tracing a buried conductor, the transmitter sends a current through the conductor. The current causes an electromagnetic field or signal around the conductor. The receiver detects the field, allowing you to trace the path on the surface. There are 3 methods of applying transmitter signal to a conductor: the direct connect method, the dynacoupler method, and the induction method. This pedestal is a good example of where you can use the direct connect method because you have access to the shield of the buried cable. First, plug the direct connect transmitter cable into the transmitter output jack. Next, attach the black clip to the ground rod and place it in the ground 90 degrees from the suspected cable path. Now, this is the suspected cable path, so the ground rod goes over here. Now, connect the red clip to the cable shield. If the shield is grounded at the contact point, you'll need to remove the ground. To check the batteries, press and hold the off key. A solid tone means the batteries are good. A beeping tone means the batteries are low, and no tone means change the batteries. It's a good idea to check the batteries after you finish using the locator to ensure they'll be good the next time you use it. Successful location of a buried conductor using the direct connect method requires a complete circuit. The circuit goes from the transmitter through the conductor back to the transmitter through a far end ground and the ground rod. To test the circuit, press the ohms key. You should hear a solid tone like this, indicating the circuit is good. A beeping tone means you have a marginal circuit. A no tone means the circuit has a high resistance or is open, and the transmitter may not be able to apply enough signal for tracing. If the circuit is good, press the trace key and select the 577 Hz frequency. You should use this frequency with the direct connect method when the far end is bonded. If it's not bonded, use 33 kHz or 200 kHz. For longer tracing distances or deep cables, you can apply a higher output by pressing the output level key.
When using the direct connect method, the transmitter output current number is displayed. A display of the word low, or a number less than 50, indicates a weak tracing signal. A number higher than 70 represents a strong tracing signal.
The Dynacoupler is an optional accessory that's handy to have when you can't connect directly to the conductor. You can use it on metallic pipes, secondary power cables at the meter, or primary power cables at the transformer. But be sure to use your company's safety procedures. The Dynacoupler connects to the output jack with its own cable, and it's then clamped around the conductor you want to trace. Press the trace key and select the 200 kHz frequency. You should also use high power with the Dynacoupler, so press the output level key to select high output power. When surface access to a buried conductor is not available, you can still apply a signal to the conductor using the induction method. The transmitter signal comes from an internal antenna and couples onto the buried conductor. This is a good example of when to use the induction method. It's obvious something is buried here because the pavement has been repaired. Since there's no easy access to apply the signal, I'll have to use the induction method. To apply a signal, put the transmitter on the ground over the buried conductor and line up the lid hinge with the conductor path. Now, this is the suspected path, so I'll just line up the hinge like this. Press the trace key to turn the unit on and select the 200 kHz frequency. You can also use high power, so press the output level key to select high output power when the received signal is weak. You should be aware, though, that the induction method applies a signal to every conductor in the immediate area near the transmitter. Tracing the cable path with the receiver is a simple process. Turn the unit on by pressing and holding the on-off key. Notice the battery level mark on the left side of the bar graph. If the bar graph is to the left of this mark, you'll need to replace the batteries. First, select one of the 4 trace modes. Here, I'll use peak. Next, set the receiver's frequency to match the transmitter's output frequency. If you're tracing a power cable without using the transmitter, select the power frequency. Before you begin tracing, you need to set the receiver's gain or sensitivity. Find a point of maximum response over the suspected cable path. Hold the receiver at a comfortable tracing height with the receiver's handle in line with the cable path and press the gain adjust key. The receiver automatically adjusts itself for a satisfactory signal level. You can tell when to readjust the gain by watching the bar graph. If it separates nearly all the way or closes completely, Find a point of maximum response and readjust the gain by pressing the gain key.
The bar graph provides a visual indication of the relative signal strength being received by the locator from the cable being traced. Pressing the gain adjust key once sets the bar graph to the midpoint reference setting based on the strength of the signal being received by the locator at the moment the gain adjust key is pressed. Remember, you only need to press the gain adjust key once each time you wish to reset the bar graph level to the midpoint reference setting.
At any time while tracing, you can get an estimate of the cable's depth. Set the receiver on the ground directly above the cable, with the receiver's handle in line with the cable path. When you press the depth key, the numeric display shows the estimated depth and the relative signal current in the cable. The circled eye is also displayed. The current mode is useful for verifying that you're tracing the correct cable. Here, the transmitter signal was applied to the deeper cable. The other cable is carrying a weaker signal because of common grounding. This looks like two trace paths, so which is the correct one? Since the cable with the highest current is most likely the target cable, you have to check each response in the current mode. As you can see, the deeper cable has the highest current and is the target cable. To reduce the possibility that the trace signal will get onto other cables, use the direct connect method at 577 Hz with good far-end ground.
In newer models, the flashing Hertz symbol indicates alternate frequencies are available. To change to an alternate frequency, press and hold the gain key while pressing the frequency key.
When a non-metallic pipe becomes obstructed, a 3M active duct probe is a convenient device that's used to locate the problem. The probe emits a signal that the receiver can detect, allowing you to locate it. To locate an active duct probe, turn the receiver on, select the ADP frequency, which in this case is 33 kHz, then select the peak trace mode. You have to hold the receiver so that its handle is perpendicular to the duct path. So I'll hold it like this since the path is in this direction. If the bar graph stays fully closed or fully open as you're tracing the path, press the gain key. To make sure you're directly over the probe, turn the receiver until you get the strongest signal. And then move it across the path until you get the strongest signal again. To measure the probe's depth, set the receiver antenna on the ground directly over the probe and press the depth key twice for ADP depth. To locate a buried fault, use the direct connect method to apply the fault locate signal to the cable sheath. At the fault, most of the current stops traveling through the cable and travels through the earth. This causes a voltage gradient around the fault that can be detected at the surface. Using the earth contact frame, the receiver not only detects the voltage gradient, it also indicates the direction to the gradient. I'm just about set up at this pedestal to locate a fault. The direct connect cable is plugged into the transmitter's output jack. The cable's red clip is attached to the shield of the section containing the fault. I've isolated it from ground by removing the bonding straps from both ends of the section. The black clip attaches to the ground rod, and it's placed in line with the cable path. The suspected cable path is this way, so I'll put it back here. Place the ground rod as far away as possible. To verify the fault resistance and to check for foreign voltage, turn the transmitter on by pressing the ohms key. If foreign voltage is on the line, the display will alternate to show voltage and resistance. In this case, there is no foreign voltage, so it only displays resistance. If the resistance is more than 1 megohm, there is no significant fault on the section. Between 1 megohm and 50,000 ohms indicates a high resistance fault. It may not be causing problems yet, but most likely it will get worse with time. Less than 50,000 ohms indicates a heavy fault between the shield and earth. Now, set the transmitter to fault mode and connect the earth contact frame to the receiver using the earth frame cable. Insert the earth frame into the ground 1 or 2 feet from the ground rod with the green banded leg toward the fault. Turn the receiver on. Activate the fault mode. Press the reference key to set the earth frame reference value. When you find a fault, you'll use this reference value to determine if it's a major fault or not. Since the receiver's bar graph is on the right or green side, it's indicating that the fault is ahead, in the direction of the green banded leg. Continue along the cable path, inserting the frame probes every few steps while watching the receiver's bar graph. When you pass the fault, the bar graph changes from the green to the red stripe side. The fault is now behind the earth contact frame. Back up slowly, inserting the frame every few inches until the bar graph returns to the right or green side. When the bar graph changes from one side to the other, turn the frame 90 degrees to the cable path. When you locate the point of bar graph reversal, the fault is beneath the center of the frame. You'll now have to determine if this is a major fault. Back up 1 or 2 feet, so the earth contact frame is not over the fault, and compare the fault signal strength to the reference value measured at the ground rod. If the reference value and the fault value are within 20 points, you've located a major fault. If the fault value is less than the reference value by 20 points or more, it's most likely not a major fault, and you should continue locating. This completes the presentation on the Dynatel2273 Advanced Cable and Fault Locator. For more detailed instructions about its operation, refer to the instruction manual. And for more detailed instructions about locating with this test set, 3M offers an instruction manual on cable and pipe locating techniques. If you need information on ordering or repair, or if you have any additional questions, please contact your local 3M sales representative. You can also call our toll-free technical assistance number at 1-800-426-8688.